So can you elaborate on the challenges and benefits of collaborative work in this kind of environment?
Yeah. So when we were at ODSC back in last at ODSC West where we met, we were talking with a Fortune 50 company, huge company, and the way they manage their notebooks is they have a Slack channel where they will put different emojis under, like, different reaction emojis under the Jupyter notebook file to say, okay, I'm not in the file anymore. Oh, okay, now
Oh,
I'm in it.
goodness.
Nobody else go in, right? And you had to look and see
Oh,
what
no.
emoji was there. And that was the way they managed it. We had a similar experience at Data Robot. One of the things that we were doing towards the end of my time there was building a COVID forecasting system during the pandemic for the US government. And that was a really, really cool experience. But a lot of the work that we did was in notebooks. And, but we were trying to work, kind of follow the sun type environment so that we could have people in the US, in Ukraine, in Singapore, constant in India, constantly working on these projects, and trying to manage notebooks in an environment like that is a disaster. It's a mess, right? Especially because most people who use notebooks are using them locally. And then you run into all kinds of, like, dependency problems. Which version of Python are you on? Oh, I'm using NumPy 1.21 instead of Num 1.23, and that's not compatible with TensorFlow, or whatever it might be, right? And so that sort of experience is a nightmare. And so really all of the innovation that's happened in the notebook space over the last, say, 5 or 10 years has been trying to become more collaborative. Google Colab is probably the first example of that, but there's others like Hex and DeepNote and a few others that have tried to solve this collaborative problem, but unfortunately they don't do it right. So, like, if you go into Google Colab and you've got 5 or 6 people logged into the same notebook, you've got a crazy, like, lagged delay thing going on, and then you also have to do things like locking cells. So if somebody is in a cell, then nobody else can edit it. And the big frailty with notebooks is that if you run the cells in the wrong order, or if you run them too many times, then you can get into a bad state, right? And everyone who's ever used a notebook has clicked on the restart kernel button because you've gotten your notebook into a bad state. And the only way to fix it is to turn it off and turn it back on again.
I do that constantly when I'm working in notebooks, even if
Yeah.
it's just for me, even
Yeah.
if it's just like a teaching material. I am constantly like, okay, I've added kind of a new section here. Let's make sure that if I restart the kernel and rerun this notebook, everything will still work. And for the cells, so that means that even from the beginning, any cells that I know would take a long time to run, I'll have them work with like a trivial amount of data so that I can
Yeah.
just make sure. And then it's kind of like when I get to the end and I'm like, okay, now it's time to like run it overnight or whatever. I change that an index so that I'm working with like the full amount of data.
Yeah. Yeah. That's a nightmare, right? Can you imagine, like, when they developed these Jupyter back when they were called IPython notebooks back at Berkeley, when they first developed them 20 something years ago? The first version of these guys, I can't imagine that it had a restart kernel button on it, right? Like, the way that it had to have happened. And I'd love to hear, like, a firsthand account of this, is that, there people develop IPython notebooks and they realize, oh, my notebook's in a bad state. And then they've got to, like, close it down, go to terminal, control C, and then restart the notebook and all that sort of stuff. At some point, somebody goes, well, why don't we just put a button there that'll do it? Nobody would develop the restart kernel button from first principles. Like, that's never going to be in anybody's design document. It's a Band-Aid fix for an architectural problem. And so that's the big reason why notebooks are unusable in production. And so, but the crazy part is that all the collaboration, all the innovation in that space is around collaboration. It's putting them in the cloud. It's making it where lots of people can log in. But the big problem is, if you do have lots of people logged in, it's way more likely to get into a bad state. And so you're constantly restarting your kernel. So the thing about Zerve is we don't have a restart kernel button, but you can still have 10 or 12 or 15 or 100 people logged into a project, all of them running code, all of them interacting, and you're always guaranteed to get exactly the same output every time. So no restart kernel button. We didn't reuse a single line of Jupyter code, whereas most of the notebook competitors just forked Jupyter and added some bells and whistles.
For sure. That is exactly what they did. All right, so walk us through a bit of walk us through a user journey. So what can I be doing in this flow that I couldn't do in Deep Note or Hex or Colab. Yeah, give me kind of a story here.
Yeah, so Zerve is language interoperable, first of all. So most teams on these data science projects are operating in multiple languages. So you might have some data engineers that are working in SQL. Maybe they're pulling data out of like a Snowflake or something like that. And then they would normally say, okay, where do you want me to land this data? They might make a temporary table in Snowflake, or they might dump it as a CSV file somewhere, or store it as Parquet, or who knows what they would do with it. And then they hand it off to a data science team. And maybe that data science team is using, maybe you've got some old school folks that are using R. Maybe you've got some, because the R guys will tell you that their visualization stuff is so much better than Python, and maybe they're right. And then you've got some data scientists that are, all the young folks that are using Python, and they're going to do their development stuff. And so they're working in their languages. And, maybe your R guys are in R Studio or Posit, like it's called now. And, maybe your Python guys are using Jupyter, or maybe they're in PyCharm or whatever. And then they get done with that project, and then they've got to go to ML to the DevOps guys, right? They've got to say, okay, we've got this project, and now we need to like spin up a server and get you a Docker container, and do this productionizing whole thing. And so you've got like 4 or 5 teams that are all operating in different languages. Zerve lets them all work in the same environment. So in Zerve, you can do things like SQL query a pandas data frame. You can write ggplot code to visualize data from some Python data structure, that sort of stuff.
Wow.
So it's completely language interoperable in a really, really seamless
That's
way.
cool.
And we're not doing code conversion on the back end. What we're actually doing is serializing your outputs. So if you create an artifact throughout the course of your analysis, like say a model or a data set or something like that, we're going to persist it for you so that you can actually reference it. And we persist it in a really clever way so that you can interact with those basic data types in any language that you want. And so that language interoperability really opens the door for a lot of collaboration. That's the second key. The first one is stability. So no matter who runs what, when, or how many times, you're always guaranteed to get the same output. And the second one is language interoperability. So no matter who's on my team, they can all interact with all the different projects, parts of the project, using the language that they already know in the same place, which is great.
You used the term project a few times, and so I'm guessing that is quite a different experience from what we would typically call a notebook. It sounds like it's a separate thing, and maybe that's somehow how you're able to get this consistency.
It's canvas based. So if you imagine a DAG, directed acyclic graph, we're essentially, when you use Zerve to write code, you're essentially linking together blocks or nodes in that graph, and then the code executes from left to right. And so your first block might be a query against, say, Databricks or a Snowflake or something like that, and then that might connect to a Python block, where you might filter the data or perform some transformation or start some sort of a machine learning pipeline, and then that might connect to an R block or whatever it might be. Right? It's very flexible.
Nice, very cool. And so, if I'm coming in and I want to do some exploratory data analysis, I'm guessing that I start off by creating a node in which I'm importing the data. And then I have that visually flow to a node where, say, I'm doing some visualizations. And then can I, in this DAG, can I have like a one-to-many kinds of relationships?
Yeah, absolutely. The other thing that you can do that's really important for collaboration is you can run as many blocks at the same time as you want. So if you look at like a Jupyter is single threaded. So if a cell is running, you might as well get a coffee, or even worse, go have a conversation with somebody, right? And as a data scientist, I try to avoid having conversations with people as much as possible.
Sure,
But in Zerve, because the way the architecture is set up, I can take my DAG and I could say go from one block to 3 different forks of that block, and I could execute those all at the same time. So if I want to train, say, 10 models at once, then I can kick those off and let them all do their thing, and I can still be working in another block, writing more code or running more code or whatever it might be.
Nice, very cool. And then all right, so I could have my leftmost node, I'm importing data, and then I have this visualization node, and then I could have multiple nodes coming off of that visualization node where maybe I'm working on one of them, because I've decided that for me and maybe people on some like team A that I'm managing, we're working on some machine learning model. Meanwhile, there's another group, team B, that's a whole other group of people. I don't necessarily need to be working with them. Maybe we have like a weekly stand up together, and they're more interested in getting insights from the data. So we have this team A is doing machine learning. They've got a node coming off of the import, and they're doing all this machine learning stuff and having as many nodes, and they're kind of part of this graph. Meanwhile, there's another team doing analysis and insights. Um, and so that's the kind of flow. You can have lots of different groups collaborating in the same code. We're guaranteed to be working with the same versions of software libraries, I guess. Is that something, where do you specify that in the flow, the kind of the software libraries, the dependencies?
Yeah, so every canvas is supported by a Docker image that has all of your dependencies in it, and that's editable by the user. So if I want to add PyTorch, or I want to add in XGBoost or some Hugging Face libraries, or whatever it might be, then I just add those in, rebuild that Docker image, and then that new environment is ready to go. So you don't have to worry about it, right? So if a new person joins your team, instead of them spending the first week setting up Python and figuring out their virtual environments and all that jazz, you can say, okay, I shared with you our default data science environment. You're ready to
Right.
code on day one.
Cool.
Yeah.
Nice. That's
It's handy.
great. That sounds so easy.
Mm-hmm.
It sounds amazing.
It's fantastic. It really is. It has really been a great experience to kind of take a lot of the frustrating challenges. We call it data science Stockholm syndrome. Like, data scientists have sort of been held hostage by. In fact, we actually said that in Stockholm after we did and after we launched our beta in Paris at JupyterCon. We went to Stockholm and we talked about the data science Stockholm syndrome, and nobody really got it. Apparently, that's not a thing there.
They just call it the syndrome.
Yeah, yeah, the syndrome. So yeah. It's been really cool to kind of take all the things that frustrate data scientists about the way the workflow goes and try and build real kind of serious fixes for them.